expand next. If it is possible to expand, then we have to apply DFS. Otherwise, we have to kill that node and move one step to back and identify what is the next possibility to expansion. Okay, that type of technique, that method we are using in a backtracking. But here branch and bound is a different way, okay, to solve that type of problems. So only two problems are there here. One is 0 on knapsack problem, 0 by 1 knapsack problem, and another one is traveling salesperson problem. Traveling salesperson problem. So only two problems we need to solve here, knapsack problem and traveling salesperson problem. But in the branch and bound technique, again three techniques are there. One is FIFO BB, and LIFO BB and LCBB. So same problem we can solve by using first in first out branch and bound technique, last in first out branch and bound technique, and least cost branch and bound technique. So branch and bound technique is nothing but first in first out branch and bound, last in first out branch and bound, and least cost branch and bound. Totally three techniques are there in branch and bound. For each problem we can solve by using these three techniques also. Okay, so what is the difference between these techniques and what is the meaning of branch and bound compared to the previous backtracking? First we need to discuss, but the entire part of this chapter of branch and bound, it's the overview of three techniques with two problems. You have to practice with all the terminology and calculation. So my sincere advice to all of you, please take the one running notes and write the comments and write the points which are important to you. Those points are very much useful for the implementation of zero knapsack problem and traveling salesperson problem. Without practicing and without writing, but just seeing by using your mobile phone or laptop, by doing other activities, it is impossible to learn branch and bound technique with calculation. So all of you please, okay, take your running notes and copy the information when it is important, and when the calculation is required, we will do the calculation for the examples also. Okay, first we will discuss about the basic terminology for branch and bound. After that, we will see the calculation and starting the example, how we have to practice those techniques. So first we have to start with the general method. Okay, branch and bound. What is the meaning of branch and bound? It is very similar to the backtracking. Okay, for generating the state space tree, but the difference between backtracking and branch and bound I will explain with an example. Okay, suppose we are starting with node 1 for some problem. Okay, we are starting the solution by using the backtracking first. Okay, then we have to compare with the branch and bound. What is the identification here? Suppose it is zero knapsack problem. First we have to extend the first object, it is 1 or 0. So two nodes are generated. Okay, two possibilities are there. But in the backtracking, with these two possibilities, first you have to generate only one possibility in the backtracking by using DFS. Backtracking is not always you are using DFS. Only out of two possibilities, even though second possibility is there, we never expand the node 1. Okay, you have to expand node 2 only. Okay, node 2 only. After that, next you have to take the node 2. Again, second object you have to consider the knapsack problem is already completed in the previous class. Okay, again we have to take one node 3. Okay, x2 is equal to 0 is there. We never expand at this moment, and node 3 only we are expanding. From node 3, next we have to expand node 4. There is the decision of the third object. Okay, there is x4, x3, and if there is a possibility for x3 is equal to 0 is there, but we never expand at this moment. Further, we have to identify any possibility to expand based on the bound function. If there is no possibility, then move to the backtrack and identify what is the next possibility from previous node. That is called backtracking implementation. From here, again 1 x4 is equal to 1, we are expanding. Okay, if it is an answer node, we will announce the answer node. If it is not an answer node, then it is not possible to extend further, then move to the one step back and identify the next possibility 0, that is 7. If there is not an answer node and it is not possible to get the solution, again move to the back. There is no possibility, again move to the back. Under 2, we have to expand, that node is 8, that is x2 is equal to 0. Like this type of each and every step we are expanding in the depth to only one adjacent nodes instead of all the possibilities from the current node. Okay, by using the DFS concept, that is called backtracking. Means move to the forward up to the depth. Okay, if any possibility to get the result, then we will announce the result. Otherwise, if there is no scope to get the answer node, at that moment we have to move one step to back. Means we have to move to the parent of the current node and identify what are the possibilities from the current node. Those possibilities you have to expand one node at a time. Up to depth you have to cross check. Again, if there is no possibility, again move one step to back. Like that, all the possibilities you have to expand. Okay, by using the same technique. Okay, then we have to identify how many possible answer nodes are there. We will display those answer nodes. Okay, this process we are calling as a backtracking. 1 minute. Mm. Mm. Okay. Mm. Mm. Okay. Class లో ఉన్నా లేదంటే. Mm. Okay, that is called backtracking representation. Next one is branch and bound. How branch and bound will work with the same environment or the same example. First, we have to take the node 1. First, we have to take the node 1. From this node, it is a live node now. Okay, from this node, we have to expand all the possibilities. Okay, how many extension possibilities are there for this live node as a E node? Okay, we will expand all the possibilities, not as a DFS. DFS will expand only one node at a time, and from that node again it can be expand only one node. It is like as a BFS. Okay, some extent. That is, all the possible expansion is done from that live node. After that, again 2, 3, two nodes are available to expand from here. Based on the technique, here the technique will applicable. What are the techniques are available? FIFO-BB, FIFO, and LIFO-BB, and LCBB. So suppose we are taking FIFO-BB, first in first out. Out of 2, 3, which node is generated first? 2 only generated. Then we have to expand all the possibilities from 2. That is 4, 5. So now those 3 live nodes are available, 3 and 4 and 5. Again you are applying FIFO method you are using. Which is first generated? 3 only. Out of 3, 4, 5, which is generated first? 3 only. That is 6, 7. Please expand that node. So for each and every step to extend the state space tree, okay, out of the live nodes, out of the existing live nodes, which node we have to take as a E node? Everyone is perfect in the representation of live node, E node, dead node. We clearly discussed in the previous class. Okay, in a state space tree, when you are using calling as a particular node is a live node or E node or dead node. So live node is nothing but node is generated, not expanded up to now. E node is nothing but which node out of the live nodes, one node we have to select to expand now. So what is the node currently expanding? That node we are representing as a E node. What is the meaning of dead node? Dead node is nothing but in a state space tree. Okay, any node there is no possibility to extend or expand. Okay, that is called dead node. Or one more condition is also there. Any node there is no possibility to expansion further. Means all the possibilities of the children are generated. That node is also we're calling as a dead node. Dead node is there is no possibility of expansion. It is called a killed Poisson bonding function. Second one is already expanded. There is no scope for further expansion. Those two possibilities we are calling as a dead node. So the criteria for branch and bound is, okay, branch means which node we have to expand next based on these 3 techniques. So these 3 techniques we will discuss with an example. I will explain what is the meaning of FIFO, LIFO, and LCBB. It's very simple. If the calculation is everything is same, but which live node we are selecting for next expansion is based on these 3 techniques. Okay, but once we are selecting a particular node, we have to expand that node for all the possibilities. Means we have to generate all the possible children of the particular node. There is a difference between backtracking and branch and bound. Okay, so suppose 3 is selected, next 4 is selected. What is the expansion for the possibility of 4? We have to expand those all the possibilities. Okay, that is called branch and bound and backtracking difference. Next we will see some basic terminology. Which that same terminology we already discussed before, backtracking representation. about state space tree and node representations. Okay, I hope everyone is clear what is the meaning of state space tree and what is the meaning of solution state, answer state, and the state space tree. What is the meaning of solution state? Solution state is nothing but in a state space tree, suppose some nodes are generated, this node I want to call as a solution state is nothing but the path from root node to this node means 1, 2, 4. There is a path. Okay, this path is possible to represent by satisfying some condition. Then that is called a state space solution state representation. Okay, next one, what is the meaning of answer node? Answer node is nothing but it is already solution state in the state space tree. Okay, but we have to expand this all the possibilities by satisfying the implicit constraint. Any answer node we are representing means we are reaching the solution of the given problem. That node we are calling as a answer state. Answer state is nothing but one of the solution state which is satisfy the implicit constraints 100%. That state we are calling as a answer state. Generally we are calling as an answer node. Okay, a particular node. In the previous examples also given knapsack problem. Okay, we identified the possibilities of answer nodes. Okay, huge number of answer nodes are there with different profits. Out of that we are selecting the maximum profit to get the optimal solution. Okay, which is satisfy the implicit constraints out of the all the solution state. Solution state is nothing but is the increment result. Okay, that result we have to announce from the path from root node to the particular node in a solution state space tree. Okay, that is called a tree we are representing with solution space is called a state space tree. There is a third definition. Okay, next definitions are very important for branch and bound implementation, and you all aware of these nodes. We already discussed it in the previous example also. Again I will explain because these definitions are very important. Okay, please listen carefully. 1, 2, 3, 4. Without knowing the meaning of these definitions, we never get the meaning of branch and bound implementation process. Suppose some graph is there or some input is there. 1, 2, 3, 4 is a graph implementation. Now I want to identify a solution. Okay, for searching the BFS or something. Suppose we are assuming as a BFS. Okay, how we have to implement? Okay, for the implementation process, live node, E node, and dead node. Please listen carefully. The same concept we will implement for further calculation also. Without knowing this, it is impossible to learn any type of technique in the branch and bound. Suppose we are starting the process with 1. So live node is 1 means node 1 is generated and not expanded up to now. E node and dead node are empty at the initial stage. Okay, there is a live node representation. So next one in the BFS, what we have to do? BFS is at the first stage. Which node is available? That's we have to expand. Means identify the adjacent nodes. What are the adjacent nodes for 1, 2, and 4 are the adjacent nodes. So 1 is 2, another 1 is 4. So from one expansion by using the logic of BFS, 1 is expanding is nothing but the current live node we are taking for execution, and that we are representing as a E node. Means now we are executing 1. That's why live node is converted as a E node. Okay, after executing this 1, we will get the answers of 2 nodes are generated. Another one is 2, another one is 4. So those 2 nodes are generated and not expanded. Then we have to write in a live nodes 2, 4. Once after 1, any other adjacent nodes are there? No. Then we have to complete that expansion of the 1. Then you have to move to the dead node. Dead node is nothing but from 1 there is no possibility to expansion, or from 1 all possibilities are expanded. Then that possibility we are calling as a dead node. So 1 is moved to dead node. So as per BFS technique, 2, 4 are the live nodes. Which node we have to select? Okay, BFS is nothing but it is used based on the queue, na? Means first in first out. Which is generated first? 2 is generated. That's we have to expand. So 2 we have to expand. Any adjacent which are not visited up to now, 3 is available. So 3 is generated. So 2 is expanding, 3 is generated. That 3 we have to add it to the live node. Any node which is generated newly, the default we have to add it to the live node. If any other possibility to add from two adjacent, any other adjacent nodes are which are not visited up to now. Okay, one is available, it is visited already. Okay, only 3 is available, that is already written. So this is the only possibility to expand. So after expansion of total value, we have to move to the dead node. So what is the next value? 4 and 3 are live nodes. Out of these two live nodes, I want to select one node to expand on basis of BFS technique. BFS is nothing but a queue. Queue is nothing but first in, first out. What is the first generation value? 4. Just I have to select 4. Next expansion is 4. So next expansion is nothing but from 4. Two adjacent nodes are there, 1 and 3, but these two adjacent nodes are already visited. There is no scope for expansion. Then we have to move to the dead node. If any scope is there, then we have to expand, but there is no scope. Then we have to move to the dead node. Next, only one live node is there, 3. Just we have to take for expansion. From 3, any adjacent nodes are there? No. Which are not visited up to now? No. Then we have to move to the dead state. Okay, there is a 3. We have to move to the dead state because there is no unvisited nodes which are adjacent to 3. So there is no expansion for 3. So all nodes are visited. Okay, this is the process of what is the meaning of live node, E node, dead node based on first in, first out concept. First in, first out. In the branch and bound also, first in, first out is nothing but like this type of technique we will use. Last in, first out is nothing but out of the selection of the live nodes, which is the last generated, thus we have to expand first. Okay, that is called last in, first out. Okay, each and every time which E node we are generating next based on these techniques. Based on these techniques. Simple. Which node we are selecting as an E node is nothing but which node we are using as a E node, that's we have to use technique. Here we are using FIFO branch and bound representation. I hope this meaning of E node, live node and dead node explanation is clear to you, because this is the second time we are explaining okay what is the meaning of these nodes. This explanation is very important to further calculation. Okay, the meaning of FIFO, LIFO, LCBB is also we are using based on this node generation only. Okay, we will move to the basic concepts. So I hope everyone is clear with these definitions. A node which has been generated, all those children have not yet been generated is called a live node. A node is generated and children are not generated up to now. That is called a live node. Next one, what is the meaning of E node? E node is nothing but it must be a live node, and whose children is currently being generated is called a E node. Okay, now it's expanding in the process, that is called E node. What is the meaning of dead node? Dead node, two conditions are there, which is not to be expanded further. There is a one condition, and the second condition is all whose children has been generated. All the children are already generated, or there is no possibility to expansion from this node. Okay, one children is also not possible because it's a kill node. Okay, based on bounding function, it is not possible to extend from the particular node. There is a one condition, or all the possibilities are expanded. That possibility we are calling as a dead node. Next one, last one, bounding function. Bounding function is nothing but it's very much helpful for us, means to produce the efficient solution within a short of time. We can use bounding function. Bounding function is nothing but it is a function or condition. We have to specify a particular node. Is it possible to from this node? Is it possible to reach the answer node or not? Okay, if it is not possible to reach the answer node, we have to kill that node from that particular extension. Then you have to move to the further. Okay, for expansion of remaining possibilities. Suppose I want to start with 1. It's generated 2 and it generated 3. From 2, assume 2 and 3 are there to expansion next. From 2, I have a function to identify there is no possibility to reach the answer node by using the 2. Then automatically I have to use kill this node, means there is no possibility of expansion of, there is no need of expansion of node 2. Then automatically I want to use 3 for further expansion to reduce the space to set to answer node by using the bounding function. Okay, bounding function is nothing but where we have to specify some condition. That condition indicates that from the particular node there is no possibility to reach the answer node. Then that node we have to specify it is killed, or we have to stop the expansion from the particular node. Means we have to make it that node is a dead node. Okay, means we are producing efficient results. Okay, without searching all the nodes in a state space tree. Okay, efficient results we are producing within the short time. For that purpose, we have to maintain the bounding function. Branch and bound is nothing but one is the bounding function. Next one is how we have to branch the one node to expand. Okay, that is called branching. Branch and bound is nothing but bounding function is one key point and branching is the another key point. Which branch we have to expand further based on the technique of LIFO, FIFO, and LCBB. Okay, and here all of you please observe. Okay, what is the difference between backtracking and branch and bound? Please observe depth first node generation. Okay, with bounding function is called as a backtracking. Depth first node generation is nothing but is already discussed in the previous. What is the difference between backtracking and branch and bound? That concept we have to specify. Backtracking is nothing but only one adjacent node we have to expand. There is a simple logic of DFS. Okay, there is a node generation, and every time you have to cross check in the previous examples also. Is it possible to kill or is it possible to expand? Okay, that is called a bounding function. Okay, if these two techniques we are using, that method we are calling as a backtracking. And here, branch and bound, the state generation methods in which E node remains the E node until it can be dead node. Means out of the set of live nodes, which node we have to select as a E node with bounding function representation is called as a branch and bound. Okay, branch and bound is nothing but we are using the bounding function again like as a backtracking, and which branch we have to expand means which live node we have to expand next as a E node, that is called as a branch and bound technique. Okay, this is the basic things. Okay, we will discuss here bounding function and live node, E node, and dead node. If you have any doubt, please type in the chat box. Otherwise, we will move to the next topic. Up to now, some technical terms we already discussed. If you have any doubt in these technical terms, okay, you can type in the chat box. Otherwise, we will continue with the next definitions. Please type in the chat box. Not only the doubts, if you are comfortable with these definitions, please type no doubts or yes, concept is clear. Okay, like that. Without that feedback, we just giving just broadcasting the knowledge. There is no use. We want to cross check that is it reached to the student or not in a right way. So please give the message in the chat box. Yeah, any doubt, please. Branch and bound is similar to BFS for only one technique, that is called FIFO. This slide indicates that branch and bound is nothing but it is a BFS we are using. There is only one technique, that is called FIFO BB. It's similar to BFS, FIFO BB. LIFO BB is nothing but last in first out BB is nothing but in the branch and bound we will use D-search. I hope everyone is comfortable with D-search also. D-search is nothing but BFS plus stack. Same BFS algorithm with stack representation is called a D-search. Next one is LCBB is there. Third method, least cost branch and bound. Okay, this is also BFS representation, but it is not based on the queue. It is based on the least cost. The node you have to select not based on the queue, based on the least cost. Out of the set of live nodes, which node contains the least cost value, that node can be selected and implemented like as a BFS. Okay, there is a difference between that. The same explanation is available in this slide. What is the meaning of this is the branch and bound refers three types of techniques based on the selection of. Suppose we are using the background method is BFS, that is called FIFO branch and bound. Suppose we are using the D-search in the background for the branch and bound representation, that is called LIFO. And one more technique is there, that is called LCBB. Then we have to use the technique based on the selection of the live node which contains the least cost. We will discuss later with an example. With the least cost, that is called LCBV. So three techniques we are discussing for two examples here. We already discussed the same condition. What is the meaning of bounding function? Bounding function is nothing but before generating any live node as a E node, okay, then it can be cross-checked with some function or some condition. Is it possible to reach the answer node or not? If it is possible to reach the answer node, then we can expand that node based on the logic of LIFO, FIFO or LCBB. If it is not possible to reach based on the bounding condition, we can kill that node. Means you have to stop the expansion of a particular node. There is a meaning of that. Okay, that is called bounding function representation. Okay, remaining thing is we already discussed in the previous explanation. Okay, next one is LC search. It is a new technique which we have not discussed up to now. There is BFS and D search we are already completed. Okay, that is called FIFO BB and LIFO BB. Now we are discussing a new logic that is called least cost search. Okay, how it can be defined is there is some function for representing the cost function here. Cost function f of h of x plus g of x, that is a cost function we are defined. What is the meaning of h of x is nothing but suppose from a node 1 to node 2, node 3 and node 3 to node 4 and node 5. Assume suppose it is a x. It is a x. We are calculating the cost of x. Now we are calculating the cost of x is nothing but f of h of x plus g of x. F of h of x is nothing but what is the cost we are calculating from the root node to the particular node, that is called h of x, and g of x is nothing but from particular node to answer node. What is the estimation cost from particular node to get the answer node, that is called g of x. So f is nothing but it is a increasing order function we are using on h of x. Okay, so we are calculating the every time cost function. Okay, which one is the best and which one we have to get the answer node very quickly. For that purpose we are using this. There is the c of x is f of h of x plus g of x. H of x is nothing but what is the cost we are already completed from the root node to the particular node x representation, that is called h of x, and g of x is nothing but from this node to root node what is the estimation cost, okay, for getting the answer node, that is called g of x. The total value, it is estimation and it is a exact value, that is the total value we are calculating, that is called a c of x. That is called least cost function. It is the only general representation or analytical notation representation. In the examples we will see how we are implementing for least cost representation for selecting the results. And BFS and DFS also is the special cases for least cost search. Is nothing but the BFS is nothing but it is a first in first out branch and bound. DFS is nothing but a last in first out branch and bound. LC search is nothing but LC branch and bound. These are the two techniques. That's why we are specifying that those two techniques are special cases for LC search also. And one algorithm is there, okay, for LC search. This algorithm is also very simple. That is, please see here. It is always implemented by using the linked list concept. Linked list concept. This algorithm is implemented by using the linked list. One node we have to create. Every time any node can be added, okay, that can be added to the linked list. So what is the logic for least cost is, as per our previous discussion, live node, E node and dead node are there. For an example, we already discussed these three concepts. Here, after selecting one node as a live node, suppose one is selected, first you have to cross check if it is answer node in the tree, then you have to declare that answer. Otherwise, take that node as an E node, take that node as an E node and repeat this process. What is the process is, for expansion of 1, how many children are there? Okay, for each and every children we have to generate and we have to cross check is it answer node or not. Okay, for each children of E, that is E we are assuming, T is the first one, E we are assuming by adding this one node we have to generate children. If it is answer node, then produce the result. Okay, it is not answer node. Then add this x to means this node to live node. Okay, and the parent of this 2 is 1. In the linked list, we are representing parent of E. We have to specify the link. Na? This 2 link is parent is 1. We have to repeat this loop again for each x means so 3 also we have to generate and identify is it answer node. Then we have to announce the result. If it is not answer node, then add to x and make parent as a previous value E. It is a x. Okay, like this we have to add all the childrens like as a linked list representation, like the same regular process. After that, if there is no more live nodes means no answer node. If which node we have to select next out of 2 comma 3. Okay, after generating 2 and 3 as per our simple example, which node we have to generate next based on the cost function, which cost is least. Suppose this cost is 10, this cost is 20. Okay, which is the least cost value, that's we have to expand. There is no concept of LIFO, last in first out, and there is no concept of FIFO. Out of the set of live nodes based on this call of LC set, which node cost is least, that is either first one, middle one or last one, that node we have to expand next. Suppose 4 comma 5, this cost is 15, this cost is 30. Okay, out of next step, this cost and this cost, these three are the live nodes. 15, 30, 20, what is the least cost that can be expanded first? Suppose it is 25, all of you please observe, 25, 30, 20, 3 nodes are live nodes, is ready to expand. Which cost value we have to expand? 25, 30, 3 means 20, 20 we have to expand. Least cost node we have to expand for getting the answer node very quickly compared to the remaining nodes. There is a process of LC set. The same process we will use for the implementation of the example also. Okay, this is a simple algorithm for that gives the meaning of how LC sets will be useful. So we will solve the first example. Okay, all of you please note down this example first. After that we will implement this. First one, 0 and knapsack problem. 0 and knapsack problem by using FIFO branch and bound. After that we will continue with LCBV, least cost branch and bound, followed by last in first out branch and bound also. First we want to implement FIFO. FIFO is nothing but based on BFS logic. Okay, branch and bound technique based on BFS. First we want to see the basic terminology of knapsack problem. What is the basic terminology of knapsack problem? Okay, I hope it is the fourth time we are discussing about knapsack problem. How it can be defined? Knapsack problem. Knapsack problem is nothing but okay, one bag is there means is a knapsack or container is there with capacity of m and they will give n number of objects. For each object they will give weights and each object they will give profit values also, PI values. PI values are given and weights values also given and capacity of knapsack is also given. So based on this, what they are asking is in the knapsack problem, okay, to identify maximum profit value, okay, based on which objects we have to place in the knapsack up to the maximum capacity of knapsack. Means what is the maximum profit? Maximum profit is sigma is equal to 1 to n pi xi. There is a called maximum profit value based on the selection of the object. Xi is nothing but there is a selection of the object. It is a 1, full object is selected. It is a 0, full object is rejected. Okay, for that purpose, maximum profit value we need to identify. For this maximum profit value, if we want to implement, okay, there is a condition subjected to. What is the condition? The number of weights we are placing in the knapsack Wixi must be less than or equal to maximum capacity, where xi value is 0 or 1, not the range, because it is a 0 knapsack problem. Means the object you have to select either full object or rejection also, full object you have to reject. Portion of object is not allowed in the 0 knapsack problem. I value varies from 1 to n. If you by satisfying this condition, Okay, we have to arrange the objects in a particular order for getting the maximum profit value. But here a small modification is there in the branch and bound representation is the maximum condition for getting the optimal solution. But in the least cost branch and bound representation, least cost branch and bound is nothing but minimum value we are selecting for the implementation process. That minimum value selection always it leads to the reverse representation. All of you please observe. Suppose node 1 cost value is 30. Suppose node 2 and node 3 are generated. Okay, at this moment the profit value is 25 here, the profit value here it is a 35 here. So it is a profit value. So in the least cost representation, which value we have to select 25, but as per our expectation maximum profit we require. So LCBB we are applying in this concept of knapsack problem. Knapsack is always represents the maximum, but least cost is always select the minimum value. So there is a contradiction here. That's why we want to change a small issue, a small point here. That is the profit value. We simply add minus. Means we have to minimize the profit for just for change of the calculation. At the end representation, the numbers are same. At the end of the calculation, we will remove this minus. We have to automatically result gives positive only. So I will give example. Suppose without doing this operation or without doing this modification in the problem statement, suppose 25, 35 is there in the middle of the solution. Okay, by applying LCBB, which node we have to select? Node 2 we have to select because it is a least cost, means least profit value. But I want to modify that same problem with after calculating that result 25 and 35 as is. I want to add minus for both values without changing the value. I just add the sign that is minus. So out of minus 25 and minus 35, what is the least cost value? Minus 35. So that's always reach our expectation. Minus 35 is nothing but, please forget about minus, 35 is selected. So out of 25 and 35, we want to select 35, means maximum value we want to select 35, but the logic we are using LCBB, that's why I simply add minus sign for result. After computation is same. How to calculate the profit value? Computation is same. I just add minus for that because we are there in the branch and bound. Up to now, we never use this logic. For here in the branch and bound, we are simply using the profit value calculation is everything is same. The selection of the object condition is also same. Remaining terminology, everything is same. By just adding the profit value with minus for getting the correct answer in the result. We are always focusing on maximum value, but in the least cost, the method is same. But how we have to select the maximum value by using the least cost is by just adding minus. So for zero knapsack problem, in the implementation in branch and bound, a small modification is there in the problem statement. The statement is every time we are specifying as a maximum profit value, but here minimize the profit with value of minus. So out of two solutions, one is 35, another one is 40, another one is 42. Three profits are there in the middle of the solution. Okay, as per our general statement of knapsack problem, we need to select 42, but here LCB least cost only we have to select. That's why simply add minus as per this logic is concerned. For minus, what is the least value? Minus 35, minus 40, minus 42. Which is the least value? 42 only. That's why we have to expand next. Suppose it is 50, it is 55. After next step, again out of these four values, what is the least value? 55. But original value 55 is the large value compared to the four values. Okay. To justify this condition, we are modifying this. This is the only small observation we have to make, and you have to justify why you are using minus value in the knapsack problem. Every time you are using the minus for the profit value calculation in this zero knapsack problem representation. So there is a zero knapsack problem. Remaining all conditions are same. So all of you please observe. Take one example for the implementation of FIFO-BB. All of you please note down this example, and after note down this example. This is example 1. Note down in your running notes. Okay, the capacity of knapsack is 15. M value small m is 15, and number of objects are 4. Those respective weights are 2, 4, 6, 9. Respective profits are 10, 10, 12, 18. Okay, all of you please note down. The capacity of knapsack is 15 m, n is equal to 4, and respective weights and respective profits. After that, please write one note value. This note value is very important. It is a bounding function. Okay, for bounding function updation is the second point. All of you please note down up to this part in your running notes. Then we will solve the example by continuing the calculation. First note on that part. All of you please note down this part. If you are not responding in the chat box, then how it's possible you are listening our class and how we will give the attendance? Based on your response in the chat box, we will provide the attendance. If you say yes, then we will note down your number. All of you please. The copying is over, then I will start. Please type in the chat box completed. The entire procedure. Given problem. Problem 1. With this theory part also, because this theory part every time we are using these conditions, each and every step, each and every calculation we are using note 1 and note 2. 3147 to Raghav. Why you are requesting annotated shared content? You are requesting again, then we will note down that number. Don't cross check the components which are working or not in a WebEx tool. It's always working. Don't request annotated shared content. Raghav. Noted? Noted? So this part we are completed. We have noted that information. So in the knapsack problem, the same example which we discussed previous, n is equal to 4, weights are given, and capacity of knapsack is 15, and the respective profits of those objects are 10, 10, 12, 18. Okay. Next we will start the calculation. The calculation will start by using node 1. Which method we are using? The first technique, FIFO BB. First in, first out, branch and bound. First in, first out, branch and bound is nothing but FIFO BB is nothing but BFS, bet the first set, plus branch and bound. Bet the first set and branch and bound. Bet the first set is nothing but it is a Q now. Q you always use BFS. Okay, means first in, first out. Which node is generated first? That node we have to expand first. Okay, that is first in, first out. First we have to start with node 1. Okay, as per this calculation of knapsack problem, we have to calculate every time for each node C of x, there is a lower bound of the x value, and u of x upper bound. It always represents the lower bound value representation. It always represents the upper bound value representation. What is the meaning of lower bound? How to calculate is in the zero knapsack problem we are applying with the portion of object also, portion of object, and in u of x upper bound it's accepting either only 0 or 1 knapsack representation. Means it is a greedy method representation, it is a zero knapsack representation. Portion of object is allowed in the lower bound calculation, and upper bound calculation is nothing but zero calculation is acceptable. Sir, in the greedy method we are using some technique that is called the selection of the objects in a particular order directly will get the optimal solution. Is it right or not? In the greedy method we are calculating pi by xi value. Which objects you have to consider first for doing the calculation for getting the maximum profit value in the greedy method, pi by xi value. So what is the values are there? 2, 4, 6, 9, 10, 10, 12, 18. So what is the pi by wi value calculation? 10 by 2, 10 by 4, 12 by 6. Is it right or not? 12 by 6 and 18 by 9. So for all the 4 given values, pi by w value calculation I am doing. So 10 by 2, 5, 10 by 4, 2.5, okay, 12 by 6, 2, 18 by 9, 2. So these are the values. How we have to arrange the objects in increasing order or decreasing order? In decreasing order. Means which value result is high, that object you have to take first. So it is a P1 by W1, first object. The order of objects how we have to consider for getting the maximum profit value is first value is high, first object you have to take to the knapsack first. Okay. Next, what is the next maximum? 2. Next maximum is 2, 2.5. Next 3 and 4 are same. Then any one we can select and place into the knapsack. So the order of the objects for greedy method to get the optimal solution means maximum profit. The order of the objects out of 4, which objects you have to take first and which object you have to take last is nothing but 1, 2, 3, 4. There is a standard formula directly pi by xi calculation. So this example also, like as the previous example, the same order of the objects you have to consider for getting the maximum profit value. So 1, 2, 3, 4. So first calculation C of x and u of x. So node 1 you have to start the calculation. Okay, what is the C cap of 1 and what is the u of 1? First we have to identify, then automatically we have to represent what is meant by live node, what is meant by E node, and what is meant by dead node. All of you please note down this calculation. Okay, what is meant by E node, what is meant by live node. First we are generating starts the solution with node 1. Okay, that is called a live node. Remaining 2 are empty sets. E node and dead node are initially empty. First we are starting with live node. First you have to start the calculation of node 1. Node 1. So in the node 1 we are not taking any decision up to now because it is a starting node. Please consider all objects are acceptable. All objects are acceptable based on the calculation. All objects are considerable. If all objects are considerable, 1 is the C cap of 1. What is the C cap of 1? C cap of 1 is nothing but portion of object is also acceptable. Na? So what is the status of x1, x2, x3, x4? Okay, how we are selecting? And u of 1 is nothing but the zero knapsack problem. What is the capacity of this? How we are selecting? So C cap of 1 for first node status, all objects are ready to execute, means 4 objects are given with the capacity of 2, 4, 6, 9. The order of objects also 1, 2, 3, 4, 2, 4, 6, 9. Suppose first object we are taken 2. What is the maximum capacity? 15. Second object also we are taken 2 plus 4, 6 only, maximum 15. Next objects also we are taken, okay, 6 plus 6, 12. So 2 plus 4 plus 6. Up to there is no issue, 12. Maximum capacity is 15. So what about the fourth object? Fourth object is 9. 12 plus 9, 21. Is it possible to place in the knapsack? No, it exceeds the maximum capacity. Then after placing the first three objects, what is the remaining balance is there? Only 3 units. So how much portion is possible? 3 by 9th portion only. So to place into the knapsack, based on the gridding method to get the maximum profit value. So C cap of 1 portion is allowed means first object is fully placed, second object is fully placed, third object is fully placed up to only 12 capacity we are using the knapsack. The remaining capacity out of 15 is the only 3. So fourth object capacity is 9, but 3 is available. So 3 by 9 portion only is possible to place into the knapsack. Then what is the profit? If this is the calculation, what is the profit? Profit is 1 into 10 and second object is also fully selected 1 into 10, third object is fully selected 1 into 12, next object is 3 by 9 into 18. So 10 plus 10 plus 12, 32 plus 6 is 38. But as per our previous discussion, for each and every computed value, profit value, we just add minus. So for this profit value, we just add minus. So C cap of 1 is minus 38. Okay. Similarly, please respond for U of 1. U of 1 is nothing but same as the previous one. We are using the same status of the node, but we are not allowed the portion of the object. It's only zero knapsack problem. So the same way, the order of the objects. First object is selected, second object is selected, third object is selected. Due to the reason of the capacity of the knapsack is 15. First object, second object, third object. Up to now, we are not taking any deletion of the previous status of the state space tree. So first three objects 12 is simply acceptable full object, but fourth object full object is not possible. That's why in the zero knapsack problem, fourth object portion is not allowed in the calculation of upper bound value as per the representation. That's why we are making as a 0. So previous calculation as it is, when the portion is there, we simply place 0 here because portion is not allowed. Then what is the profit value for this? Is first object 1 into 10, second object full 1 into 10, third object 1 into 12, fourth object 0 into 18. So the calculation is 32, but simply add minus as per our previous discussion of branch amount representation. So U of 1 is minus 32. Okay. So all of it is observed. There is a logic in the notation representation. Okay. Before applying the branch and bound representation, one upper value is there to cross-check the branch and bound condition. They clearly mentioned here the upper value, initial upper value is infinity. Now we are cross-checking the implementation of bounding function before implementing the next expansion. What is the initial upper value? Initial upper value is infinity. Upper value, initial value is infinity. That's we are fixed as per the procedure. Next one. Next we have to implement the current node is possible to kill or not. It is a bounding function every time we have to cross check. Okay, next one we have to update the upper value also. First we have to do the update upper value, after that we have to apply the killed node in each and every step. What is the update upper value? Initially infinity, but based on this condition, current U of x value is less than upper. What is the current U value? U of 1 is minus 32. So U of 1 is minus 32 is less than current upper value. Okay, is the update upper is possible or not? Update upper condition. So current U of x minus 32 is less than upper value. Current upper value is infinity. Infinity is nothing but largest value. So compared to the largest value infinity, minus 32 is less or not? So yes or no? Less or not? If it is less, then update upper. As per the procedure, update upper is possible as per the current calculation of U value. Okay, if the condition is satisfied, then upper is equal to U of x. So what is the upper value? Instead of infinity, minus 32 is updated based on the current calculation of U value. So as per the procedure only, the second point is implement. Every step we are implementing these 2 points. After generating every node, first you have to cross check update upper is possible or not. If update upper is possible, then after that is that particular node is possible to kill or not. Okay, a particular node X is kill or not. Here two conditions are there, particular node is kill or not. Okay, what is the condition one? If the current C cap value, the current C cap value, current C cap value is infinity. What is the current C cap value? C cap of 1 is 38. So C cap of 1 is minus 38 is equal to infinity? No. So it's not possible to kill. Next, the second condition. What is the second condition? C cap of value is greater than upper. What is the current C cap of value? Minus 38 is greater than minus 32. If it is say S, then we have to kill. Minus 38 is greater than minus 32. Is it right or not? Yes, it is correct now. Minus 38 is greater than minus 32. Please respond in the chat box. Minus 38 is greater than minus 32. 38 is greater than minus 32 na? Minus 38 is greater than minus 32. If it is yes, then we have to kill the node 1 as per the bounding function. Minus 38 is greater than minus 32. Say yes or no? No. Thank you. Minus 38 is less than minus 32. In the minus, the number value is in opposite. In the positive sense, 38 is greater than 32. But in the negative value, in the reverse order, minus 38 is less than minus 32. So this condition is also failed. That's why node 1 is not possible to kill. Means it is a live node. There is a bounding function. Every time you have to cross check. Okay, node 1, step 1 and step 2. Based on these two possibilities, is it possible to kill or not? So it's not possible to kill. Then you are using FIFO BB. You are using FIFO BB. So how many nodes are live nodes are there to take as a E node? Okay, only one node. Then first come first serve, that node we are considering as a E node. E node is nothing but is ready to expand. So what is the scope for expansion? It is a 0 knapsack problem. It is a 0 by 1 knapsack problem. What is the scope for expansion? Means first object you have to take x1 is equal to 1 and x1 is equal to 0. Two possibilities are there because it is a 0 knapsack problem. So node 2 and node 3. First expand node 2. Okay. What is the scope for node 2 is C cap of 2 and U of 2. Next C cap of 3 and U of 3. First you need to calculate these values based on the same scenario previous. Okay, that is node 2. What is the decision at node 2? Only x1 is equal to 1. If x1 is equal to 1, what is the C cap of 2? What is the C cap of 2? Every time you have to write the status of x1, x2, x3, x4 objects based on the current status of the execution. X1 is equal to 1 means first object we are fixing with 1. What about the remaining objects? Remaining objects you have to execute the greedy method concept again. Okay. So first object is 1, only 2 weights are filled. Second object, third object, there is no issue, 2, 4, 6, 12 only. So third object is again 3 by 9. 3 by 9. The same calculation of the previous. It is minus 38 because it is the same status of the objects we are placed. Next, U of 2. U of 2 also same x1, x2, x3, x4. But what is the difference between the lower bound and upper bound? Upper bound we are not allowing the portion of the object. So first 3 objects, first object only we are fixed as per the current status x1 is equal to 1. So remaining objects you have to take as per the previous logic. That is called minus 32. Same previous execution. So we have to write the result minus 38 minus 32. So then we can continue with calculation node 3. What is node 3? This calculation is different. What is node 3? x1 is equal to 0. If x1 is equal to 0, what is the C cap of 3? What is the U of 3? C cap of 3 is nothing but again for representing the 4 objects x1, x2, x3, x4 for both calculations, but we are taking the decision at node 3, that is first object is rejected. Then what about the remaining calculation? If first object is rejected, Then what about the remaining? Knapsack capacity is 15 is available na? In that situation, second object 4, third object 6. 4 plus 6, 10. Remaining 5 is there. So next object we are selecting 5 by 9 portion. Okay, this portion is allowed. So what is the profit value? Profit is always calculated based on minus of, okay, 0 plus second profit is 10, third profit is 12, fourth profit is 5 by 9 into 18. So 10. Total value is minus 32. Okay, similarly for u of 3 is nothing but portion is not allowed, but the status is same. X1 is equal to 0, we are selected here. 1 comma 1 means 4 plus 6, 10. 10 followed by portion is not allowed, 0. Profit is minus of 0 plus 10 plus 12 plus 0 is minus 22. Okay, so after completion of these two calculations, then we need to update the tree minus 32 minus 22. Minus 22. So once two live nodes are generated, 2 comma 3, and the expansion of 1 is over, we have to move to the dead node. This is the current status of the execution in the branch and bound. Two nodes are generated, that's why we are updating the live nodes are 2 comma 3, and node 1 expansion with all the possibilities are over, then we have to move to 1 to dead node. Then after generating the two live nodes, next further expansion is we are in the before branch and bound, first in first out. But before expanding the first in first out means first in is nothing but first node is generation node is 2 na. Before expanding this, we need to cross check the bounding function. So these two values we need to cross check. For every node we want to make live node as a V node, we have to cross check this bounding function. What is the bounding function? First we have to cross check update upper is possible or not. On what basis you have to update the upper? Current U value of any live node is less than the upper value. So please cross check what is the upper value here? Minus 32. Current U values are minus 32 is less than minus 32? No. Minus 22 is less than minus 32? Yes. Is it right? Minus 22 is less than minus 32? Please type in the chat box. Most of them are doing a mistake here because you are having a minus sign here. Minus 22 is greater than minus 32. Minus 32 is not less than minus 32. Based on the numbers, don't guess. It is a minus sign. Please remind it. Minus 22 is not less than minus 32. So update upper is not possible. So what is the second condition? So it is not updated in this current step. Kill value. Any node is possible to kill or not. So what are the conditions for that? The current C cap of x is infinity, then we have to kill. If the current C value is not infinity, then second condition, current C cap value is greater than the upper value or not. So please cross check the current status of C cap value. Minus 38 is greater than minus 32? No. Minus 32 is greater than minus 32? No. So there is no possibility to kill 2 comma 3 after applying the bounding function also. Both nodes are live nodes. If both nodes are live nodes, which node we have to select out of 2 comma 3 based on before? First in first out. Which one is the first? Second one is the first. That's we have to expand. So that is 4, 5 with the possibilities of x1 is completed, x2 is equal to 1, x2 is equal to 0. Okay, 4 and 5. Then we have to calculate what is the C cap of 4 and U of 4 and C cap of 5 and U of 5. So please go to the calculation again. At node 4, calculation is very simple, but all of you please observe. At node 4, what is the status? What is the path? The path is from node 1 to node 4. Node 1 to node 4. What are the decisions we are made? X1 is equal to 1 and x2 is equal to 1. That's you have to focus. That's you have to remember. X1 is equal, x2 is equal to both decisions we are made as a 1. Based on this, please calculate lower bound value and upper bound value for the current node. What is the lower bound value? X1, x2, x3, x4. So first two nodes are First two objects are selected. There is a decision we are made. So what is the remaining nodes? First two nodes are 2 comma 4 na. The weights of the nodes. 2 comma 4 is nothing but 6. Total capacity is 15. Okay. Next one 6, 12, 3 by 9. It's same as the first node. So profit value is minus of, okay, 10 plus 10 plus 12 plus 9, 3 by 9 into 18, 6 is minus 38. Similarly, for U of 4 is also same representation. First two objects are selected as per the current status. Remaining objects only zeros and ones concept. And profit value is minus of 10 plus 10 plus 12 plus 0 because fourth object is fully selected, minus 30, minus 38 and minus 30. Similarly, node 5 also first you have to complete. Node 5 status, what is the node 5 status in the tree? Node 5 status is different now compared to node 4. From root node 1 to node 5, what is the path? X1 is equal to 1, X2 is equal to 0. That's you have to remember before starting the calculation. That is X1 is equal to 1, X2 is equal to 0. Then what is the C cap of 5 and U of 5? The objects, 4 objects, X1, X2, X3, X4. First object is accepted, second object is rejected. So remaining objects is decision is not finalized. You have to continue based on the greedy method. So first object is selected. How much units you are placing in the knapsack? Only 2 units. Remaining 13 are there. So third object 6, 8. Remaining objects are 7 are there. 7 by 9. With the profit value of minus of 10 plus 0 plus 12 plus 7 by 9 into 18 to 14. 22 plus 14 minus 36. Similarly, 10 is fixed because first object is selected and second object is rejected. Node 5. So remaining objects are 1 comma 0. Profit value is minus 10 plus 0 plus 12 plus 0 is minus 22. So please note down 38. Please remember 38, 32, 36, 22. 38 minus 38 minus 32 minus 38 minus 32. Here minus 36 minus 22. Is it right? Once your computation is over, okay, then automatically these nodes are added to the live nodes because these nodes are generated. And once this node 2 expansion is over, we can add it to the dead node. This is the current status of the execution. Means node 1 node 2 node expansion is over. Next nodes are ready to expand is 3, 4, 5. We are implementing FIFO branch and bound. First in, first out. Okay, out of 3, 4, 5, which node we are selecting as the E node for next step? What is the first node we are generating? That node we have to take. But before taking that node, we have to apply the bounding function. So everyone is comfortable for applying this bounding function. Okay, so the same function we have to apply here. What is the function here? What is the first step you need to apply? It is update upper. Means u of x is less than upper value. What is the current u of x? First one is c, next one is u. Minus 32 is less than minus 32. Minus 22 is less than minus 22. No. Minus 22 is less than minus 22. Out of current 3 live nodes, we need to cross check. Is it possible to update? No. Next one, second one. Still based on these two conditions. What is the first condition? Any C cap value is infinity as of now. No. When we will get the infinity means you are placing the objects exceeds the maximum capacity of the knapsack, we will get the infinity. No. 38, 36 and 32. Next one. Any C cap value is greater than upper, then we have to kill. All of you please observe one by one. Here C cap of 4 is nothing but 38. 38 is greater than minus 32. No. Minus 36 is greater than minus 36 is greater than minus 32. No. Minus 32 is greater than minus 32. No. So no nodes are possible to kill as per the current status of the bounding function. So next, if all are live nodes, there is no possibility to kill. The next E node is 3. So next you have to expand 3. 3 expansion, again two possibilities are there. That is based on the second object. First object is over, x2 is equal to 1, x2 is equal to 0. So that is node 6, node 7. So next you have to continue the calculation of node 6 and 7. If you are comfortable, then you have to continue with the calculation. Otherwise, please note down node 6 and node 7. What is the node 6 status? Node 6 status is x1 is equal to 0, x2 is equal to 1. Is it right or not? Please see the table. What is the node 6 status from the root node? x1 is equal to 0, x2 is equal to 1. x2 is equal to 1. 7 is nothing but both are zeros. If one is 0, another one is 1, then what is the C cap of 6? C cap of 6 is first value is 0, second value 1, means up to now in the knapsack which object we have placed only second object. The weight is 4, remaining 11 is there, next one is 6, up to 10 we are placed, next one is 5 by 9. So profit value is okay 0 minus of 0 plus 10 plus 12 plus okay 5 by 9 into 18, 10 is minus 32. Same way U of 6. So decision is first object is rejected, second object is selected, remaining is only 0 1 concept, so portion is not allowed. So the profit value is minus of 0 plus 10 plus 12 plus 0 is minus 22. So minus 32 minus 22. Next node 7. Status is same, x1 is equal to 0, x2 is equal to 0. So if you have any doubt, please see the table 3. What is the node 7? Node 7 is x1 is equal to 0, x2 is equal to 0. From the root node, what are the decisions we are made up to now? That is both are zeros. So if both are zeros, how we are calculating the C cap value of 7 is decision of both status are 0, means knapsack is empty because both objects are rejected, capacity is 15, fourth object is 6, next object is what is the capacity? 9. Okay, so full object is possible to place. So the result of the profit is minus of 0 plus 0 plus 12 plus 18 is minus 30. Next, similarly U of 7. So first two objects are rejected. Next object is 6. Next object is 9, 15 with the profit of minus of 0 plus 12 plus 18. Minus is nothing but minus 30. Okay, so minus 32, 22, minus 30, minus 30. Minus 32, minus 22, minus 30, minus 30. Please remember first value is C cap value, next value is U of X value. So once 6 comma 7 is generated, okay, and 3 value evaluation is over, you have to make it as a dead node. So all of you please observe, now you are in the FIFO branch and bound, but 4 live nodes are there, 4, 5, 6, 7. Out of these 4 live nodes, which node we have to select for the next expansion? Which is first generated, FIFO branch and bound, which is first generated, that node we have to take for the next expansion of the getting the answer node. But before going to that, please cross check if any update upper is possible or any node is possible to kill to reduce the calculation. Okay, so what is the condition for updating the upper? If upper value is less, U of X value is less than upper, then we have to update the upper. What is the U of X value? 32 is less than minus 32, minus 22 is less than minus 22, minus 22 is less than minus 22, no, minus 30 is less than minus 32, no, so update upper is not possible. But next go to the C cap of value, kill is possible or not. Okay, any C cap of value in the current 4 nodes, is it infinity? No. Next, second condition, C cap of X is greater than upper, C cap of X is greater than upper. Please cross check the condition. Minus 38 is greater than minus 32. No. Minus 36 is greater than minus 32. No. Minus 32 is greater than minus 32 for node 6. No. Minus 30 is greater than minus 32 for node 7? Yes. Minus 30 is greater than minus 32 means greater than the current upper, that is minus 32. That's why this node is killed. Means this node 7 out of live nodes, 7 is moved to dead node. Okay, 7 is not a live node because from this node there is no possibility to get the answer node. Based on this bounding function, we are killed that node 7 is nothing but it automatically moves to the dead node. So for the next expansion of FIFO BB, only 4, 5, 6 are live nodes. Out of these, 4 is first node generated node first. That's why we have to expand node 4. So what is the possibility of expansion? Decision on node 1, 2 is over. Next decision on node object 3, that is either 1 or 0. X3 is equal to 1, that is sequence is 8 or 9. 8 or 9. Again you have to calculate the CKF value and U value. But observe, node 8 is nothing but the decisions you are taken from the starting. X1 is equal to 1, X2 is equal to 1 and X3 is equal to 1. And node 9 is 1, 1, 0. So please go to the calculation for the same values you need to calculate. That is node 8 decision on X1, X2, X3. 3 values are 1s. So what is the C cap of 8? C cap of 8 is 1, 1, 1. If 3 1s are there, your decision is finalized based on this input of 3 or 1s. So 2, 4, 6 means 12. 12 means remaining is 3 by 9. So the profit is with the profit value of minus of 10 plus 10 plus 12 plus 12 plus 3 by 9 into 18 is equal to minus 38. So similarly, U of 8 is like the same first calculation 1, 1, 1, 0 with the profit of minus of 10, 10, 12 plus 0 is minus 32. Is minus 32. Minus 38, minus 32. For next node 9. What is the status of node 9 in the tree from the root node? 1, 1, 0. First two objects are selected. X1, X2 are 1s and X3 is equal to 0. In that status, what is the lower bound? That is 1, 1, 0. 1, 1 is nothing but 2 plus 4. We are placed with 6 weight. Okay, remaining value is 6 minus 15. 9 is there. So next object is full object is possible to place 9 with the profit of minus of 10 plus 10 plus 0 plus 18, that is minus 38. Similarly, U of 8 is also same because there is no portion in the previous calculation. Okay, that's why we are placing same as it is 10 plus 10 plus 0 plus 18, that is called minus 38. So once these calculations are over, minus 38, minus 32, 38, 38, minus 38, minus 32, minus 38, minus 38. Okay. After that, we'll continue with node 5 calculation. Before going to the node 5 expansion, we need to cross check update upper is possible or not. So what is the condition for update upper? The condition for update upper is U of x, current U of x of any node is less than upper, then update upper is acceptable. What is the U of x here? Here U of x is minus 32. Minus 32 is less than minus 32? No. Minus 38 is less than minus 32? Yes or no? Minus 38 is less than minus 32? Please type in the chat box. Minus 38 is less than minus 32 or not? Minus 38 is less than minus 32 or not? Yes. If it is yes, then update upper. So from this step onwards, upper value is minus 38. Okay. Once it is updated, that's why we are updating second step first. After that we will go for the step 1, because in the step 1, based on the current value of upper, there is a condition. First you have to update the upper, next you have to cross check the bounding function. What is the bounding function? First function is no c of x is infinity as of now, that's why there is no possible. Next, second condition is any c of x of the current live nodes is greater than the upper value. Now current value, upper value is minus 38. So all of you please cross check. 4 live nodes are there, 4, 5, 8, 9. 4 live nodes are there. There is 5, 6, 8, 9. Any c of x is greater than upper. Minus 38 is greater than upper. Node 8. C cap of x is minus 38. Minus 38 is greater than minus 38? No. 9. Minus 38 is greater than minus 38? No. Node 5. Minus 36 is greater than minus 38? Minus 36 is greater than minus 38? Minus 36 is greater than upper or not? Current upper value, yes. Then automatically shielded. Again, please come to the 6. Minus 32 is greater than minus 38 or not? Current C cap of value is greater than current upper value. Minus 32 is greater than minus 38. Okay, is greater than current upper value. Yes, then we can kill it. Okay, out of 5, 6, 7, 8, instead of representation of before, we will kill the nodes which are not possible to expand next. Which are not possible to expand next means there is no possibility to get the answer node by using this node. So automatically we have to kill it. So what is the next first node? After killing 5, 6, we are moving to the dead node. What is the next first node? 8. Before branch and bound now. Next first node is out of the series of the live nodes 8. Next you have to expand 8. 8 possibilities are. Okay, this is the fourth level. X1, X2, X3 decisions are over. Next X4 is equal to 1 and X4 is equal to 0. That is node number 10 and node number 11. Then you can move to the calculation. All of you please remember the tree status of node 10 and the tree status of node number 11. Node number 10. Node number 10. The status is all the objects x1, x2, x3, x4, all objects are ones. If all objects are ones, what is the C cap of 10? If all objects are ones, is it possible to place in the knapsack? What is the knapsack capacity? 2 plus 4 plus 6 plus 9. All objects you are selected. The result is 12 plus 9, 21. But the capacity of knapsack is 15. Is it possible to place? The sum of the weights of the selected objects is exceeds the maximum capacity, then the situation C cap of x we are placing as a infinity. That is the first condition. Okay, please observe in the bounding condition, if the sum of the objects of the weights which are placed in the knapsack is greater than m, then automatically C cap of x, there is no need to calculate. When we are calculating, if you are not exceeding the maximum capacity, then only we will calculate the profit value. Okay, here if it exceeds the maximum capacity, the capacity of knapsack is 15, but we are placed 21. Okay, all the objects which exceeds the maximum capacity, that's why C cap of 10 we are fixing it is infinity. So there is no need to calculate U value also. Okay, it is always not required because it is a killed node. Next, node 11. Node 11. Node 11, what is the capacity of node 11? X1, X2, X3, all are ones, and X4 is equal to 0. There is a meaning of node 11 in the tree. X1, X2, X3 is ones, and X4 is equal to 0. There is a meaning of node number 11. At that moment, how to calculate the C cap of 11? C cap of 11 is first object, second object, third object, and fourth object is 0. The profit value is the profit representation 10 plus 10 plus 12 plus 0 is nothing but minus 32. Similarly, U of 11 is also same because we are not using the portion in the previous. Profit value calculation is also 10 plus 10 plus 12 plus 0 minus 32. So 11 is minus 32 minus 32. 10 is C cap value is infinity and upper value is also same, and minus 32 minus 32. Okay, if any situation C cap of value is infinity, that node is always killed node, because there is a bounding function. In the bounding function, the killing condition, any node is killed based on C cap of x is infinity, is always killed. Then automatically please cross check after this node generation, is it possible to update upper or not. So U cap of x is less than minus 38. No, minus 32 is not less than minus 38. That's why update upper is not possible. Next, how many nodes are live nodes are there? 9 and 11 only. Out of 10 comma 11 are generated. 10 comma 11. 10 is killed. Then we are adding to the dead node. Only 8 is already completed the expansion, and that's why we are moved to 8 as a dead node, and 10 is also killed node. Okay, only 9 and 11 are there to expansion nest. 9 and 11 are there. These are live nodes. We need to cross check, is it possible to kill or not. Okay, what is the kill condition? C cap of x is greater than upper. Minus 38 is greater than minus 38? No. Minus 32 is greater than minus 38? Please observe, minus 32 is greater than minus 38? Yes. So this value is greater than upper value. That's why we have to kill this node. There is a condition. So node 11 is also killed. Thus we have to move to the dead node. Only node 9 is available as a live node. That's we have to expand nest for echo condition. It is 12, 30. Based on up to now 3 nodes decision is over. X4 is equal to 1, X4 is equal to 0. So next we need to calculate this. That is 1101. That is node 12. Node 12 condition x1, x2 and x4 is equal to 1 and x3 is equal to 0. This is the status. So what is the C cap of 12? That is 1101. Is it possible? So what is the status here? 2 plus 4 plus 0 plus 9 is equivalent to 15. The weights of the nodes? Yes. Therefore, it is acceptable. Profit value is minus of 10 plus 0 plus 18 is minus 38. That is C cap value. Next, U value, U of 12 is 1101, same as it is of the previous value, and profit value is minus of same previous calculation because it is already in the form of zeros and lines. Next, node 13, last node in this problem. The status of that node is x1, x2 are ones. Next, x3 and x4 are zeros. If you have any doubt, please see the tree. What is the node 13? In the path from node 1, node 1, node 2, 1, node 2 to 4, 1, x1, x2, x3 and x4 are zeros. Okay, so up to this one, 1100 concept. So if it is a 1100 concept, how to calculate the node 13 is, okay, that is C cap of 13 is equal to 1100. 1100 is nothing but the profit values for this is minus of 10 plus 10 plus 0 plus 0 is minus 20. Similarly, U of 13 also 1100 is with the profit values of minus 10 plus 10 plus 0 plus 0 is minus 20. So node 13 is minus 20 minus 20. Node 12 is minus 38 minus 38. So the result we have to update minus 38 minus 38 minus 20 minus 20. So again please cross check. Killed node is possible or not. Update upper is possible. U of x is less than upper? No. Here U of x is less than upper? No. Update is not possible of the upper. Next, kill node. What is the condition on the kill node? Kill node condition. Two conditions are there. Any U of x is infinity? No. The C of x is greater than upper? Then you have to use. What is the C of x is upper? Upper is 38. C cap of x is 38. It is not greater than. 20 is greater than 38. This is greater than current upper value. Yes, then we have to kill it. Means node 12, 13 are added, 13 are killed. Then we have to write in the dead node. 13 node we are writing in the dead node, and 12 node is the only live node. Then is it possible to expand further node 12? No, because in the state space tree all 4 objects decisions are over. Okay, x1, x2, x3 and x4. These 4 decisions are over. Then 12 node is live node and there is no possible to further expansion. Okay, all the remaining nodes are killed node. Then 12 node is a answer node. 12 node is a answer node. It is the answer. So how to write the answer for node 12 is answer we have to write answer node and the result we have to announce like this. After completion of this total problem is completed, answer node we have to announce like this. The result, the maximum profit of the knapsack, maximum profit of knapsack is upper value. What is the upper value? What is the current calculation upper value? 38. So 38 minus is there, but we will remove minus in the result. Result we never use minus. Minus we are taking for the calculation of branch and bound only. Okay, the number only we are considered. Okay, the maximum profit is possible. Okay, by using the given example is based on the upper value is 38. But what is the sequence of objects? Okay, the path from root node to node 12 is, that is answer. Answer node is from root node to 12. What is the root node to 12 path? This is the path. This is the path. How you will travel up to node 12. So what is the object selection? First object is 1, second object is 1, third object is 0, fourth object is 1. Means 1, 1, 0, 1. So the path we have to represent 1, 1, 0, 1 for the objects x1, x2, x3, x4. Okay, this is the object selection, this is the profit value. This is the announcement of the result for given problem by using before branch and bound. The calculation is very simple when you know the logic. If you don't know the logic, how to update the upper and how to cross check each and every time for this killed node or not. The killed node is purely for reduce the calculation for cross checking the bounding function. If the bounding function is reached, then automatically you have to kill that node. You are satisfying that. Okay, then automatically the expansion of the particular node is not required. Remaining live nodes we have to cross check the LIFO or LCBB or LIFO node. So if you are comfortable with this calculation, then I will explain the next concept of LIFO BB or LCBB. Anyone have any doubt? For announcing the result and calculation of this tree, purely FIFO BB. Please type in the chat box. You got the logic of FIFO BB? If you follow from starting to this step, then it is very easy. If you are not followed and doing other work by opening this WebEx, then it is very difficult task to you. Node 6 and node 7 is purely based on greater than upper na. Once you are updated, the upper value is 38. Once you are updating, the upper value is 38. So 32 is greater than 38 or not? 32 is greater than minus 38. Then automatically it is killed. The condition is minus 30 is greater than minus 30. Minus 30 is greater than minus 32. Node 7 is killed in beginning. Node 8 is killed after updating minus 38. Okay, it is based on the upper value is minus 32. 30 is greater than minus 30. Minus 30 is greater than minus 32. That's why it is killed. Node 6 is killed after updating. The upper value is 38. So minus 38. When you are updating upper value is 38, then automatically 32 is greater than minus 38. That's why it's still not 6. Is it clear? Any more doubts? Please type in the chat box. If you know the concept, please type your feedback. Okay. I hope this concept is reached to you. You are clear for calculating this. So two more logics are there. Those two more logics means LCBB and LIFO-BB. Those concepts we will see based on the result. Okay, all of you please observe. We will discuss the remaining two concepts. Same problem. Next concept is, two more minutes are there. LCBB, least cost branch and bound. How we have to execute in the least cost branch and bound. We will see the tree representation. Example description is same and example is also same. Okay. Then how we have to implement this is, after generating, the calculation is also same. The formulas and killing function, everything is same. Suppose node 1 we are calculating with these two values. That is a live node. Node 1. Okay. E node and dead nodes are initially empty. So after calculating this, only one node is there. It's not possible to kill as per the condition. That's why you have to expand node 2 and node 3. Listen carefully. Once the node 2 and node 3 are generated, node 2 and node 3 are generated, and these cost functions are calculated, and again upper value is there, infinity is updated with minus 32 or something. It is not possible to kill as per the current status of the condition. Then those two nodes are live nodes. So all of you please observe. Now you are discussing about LCBB. Out of these two live nodes 2, 3, which node we have to select? Okay. In the previously FIFO-BB we are using, that's the first node we are selected. But in the LCBB, out of two live nodes, out of the two cost values, two nodes cost values, which is the least cost? Minus 38 is the least or minus 32 is the least? Okay, minus 38 is the least value, minus highest number is the least value, minimum value, minus 38. Which node it contains? Node 2. That node we have to select. So which live node we are selecting as a E node? Okay, that's based on the logic of your selection method, LCBB. Remaining process is same. Next, node 2 we are expanded, node 3 and 4 are generated. Node 3 expanded, after expansion of node 2 is over, 3, 4 are generated, sorry, 4 and 5 are generated, 3 is already over, 4 and 5 is generated, 4, 5. So out of 3, 4, 5, now your computation is, after comparison of remaining, 3, 4, 5 is the target. So out of these 3, 4, 5, after comparison of the kill node and everything, which node we have to select? So out of 3, 4, 5, which node we have to select? So based on their cost value, 38, 36, 32. Out of these three, which is the least cost? Cost function we are using now, C cap of 3, C cap of 4, C cap of 5. Which is the least cost? 38 is the least cost. That's why out of 3, 4, 5, node 4 is selected for next expansion. Okay, so this is node 6 and node 7. So next step, 6 or 7 is added, 4 expansion is over. So 3, 5, 6, 7. Again 3, 5, 6, 7. 3, 5, 6, 7. Okay, which is the least cost? 6 and 7 both are least cost. Then you can select either 6 or 7. or based on the U value you can select 7, then can continue. Otherwise, based on the C cap value, either 6 or 7, both are least cost value, anyone you can expand. So you can expand these two. So this one is the answer now. After calculating this, then automatically based on the upper value, these nodes are killed. Updating upper minus 38 is updated. Then automatically these all nodes are killed nodes. There is no need to expand because these all are the greater than the upper value. These all nodes are killed. We have to expand this also. These all values are killed nodes. This value is also good. This is the only one node is a live node after completion of the total calculation once you reach this. But all of you please observe, compared to the previous result tree representation and this result table representation, this is efficient compared to the remaining two techniques. LCBB is always gives the efficient result compared to the before BB and before BB. Okay, least cost branch and bond. Unnecessary expansions are not there. Which path gives the correct result? That path only it automatically selects based on the LCBB representation. So this is a tree, and the exact representation of this all the nodes is available here, like as the previous. Okay, billion node and everything. This is LCBB. This becomes branch and bond. How we are using the calculation in the previous, the same way we are represented here. Finally, we are announcing this node is a answer node, and based on that, that upper value, what is the current upper value, is the answer 38, and what is the path we are using here for representing this answer node? It is 1101. This is the result. This is the least cost branch and bond. But in the same way, remaining all nodes are killed based on the bounding function, like as the previous one. But the tree size compared to the previous one is very small, means the scope of the searching to identify the answer node is very efficient way compared to the remaining two techniques. Similarly, one more mechanism is also there, that is called LIFO-BB. In this mechanism also the process is same, but the logic is very simple. Okay, that logic is, suppose after node 1 generation is over, the live nodes representation E node, dead node 2, 3 are generated. Out of 2, 3, you are on the concept of LIFO, last in first out, means stack representation. Okay, what is the last in first out representation? Which node we have to expand first? Node 3. Out of 2, 3, which node is the last generated? That node we have to last in first out, which is last generated node that we have to expand. That's why node 4 and node 5. So node 4 and node 5 is generated. 3 is ended to this. 4 or 5 are there. Okay, after comparison of dead nodes, now 2, 4, 5 are available. Out of these 3 nodes, okay, if any possibility of killing, then you have to kill that node, and then automatically 2, 4 are there. Out of 2, 4, what is the last released node? 4. Thus we have to expand first. So that's why 6 and 7 are there. 7 is killed, that's why 6 is expanded. If both are killed, then only we have to come to the node 2. Expansion 10, 11. So 11 is expanded first. 12, 13. 13 is killed, then only 12 is expanded. If it is killed, then only come to the next last node. That is 10. 16, 17. 17 is expanded first. Okay. 18 and 19. Then if it is killed, then you have to move to the next values. So it is an answer node. Because the remaining all nodes are killed, then node 19 is an answer node. Then what is the upper value? Upper value is 38. And what is the path for this is 1101. So this is called LIFO-BB. This tree size is also too big because we are using the blind technique. That is called last in first out without any efficient logic. It's a blind method. That's why huge number of values we need to calculate up to almost 21 values we are calculated here for each and every step. Okay, then only we'll get the answer node. Okay, this is the way to calculate the LIFO-BB. The selection of live node to E node is the logic here. There is either LIFO-BB or FIFO-BB or LCBB. Okay, these three techniques we are applying from which live node we are selecting as a E node for that purpose only. But before applying this live node to E node, every node, is it possible to kill or not? based on upper bounding function and update upper also. So simple logic is there, the simple formulas are there. Those formulas you have to remember for applying this. If you know this logic, please try to solve these two examples also. These two solutions I will put in LMS. These two slides for the results of LCBB and LithoBB. Please try to solve. Okay. If you have any doubt, we will discuss in the free hours or practice hours for this LithoBB and LCBB by the step-by-step calculation based on your doubts. Okay, I would like to conclude here for zero and knapsack problem. Okay, in branch and bound. In afternoon, I would like to continue with traveling salesperson problem. So all of you be ready for solving a new problem, traveling salesperson problem based on the branch and bound. Thank you. Thank you, Sir Subbarao, sir.
Thank you, sir. Thank you, sir. Can I end the session, sir?
Yeah, please end the session.
Yes, sir. Thank you, sir.
Okay.